Hi, my name is Dear Tiagi, and in this video I'll be going over related rates, which is a concept you will need to know for the AP Calculus BC exam. So to start, what is a related rates problem? A related rates problem is a problem that has multiple variables that change with respect to time. And in these problems, they ask you to solve for the rate of change for a certain variable to time. So the process for solving a related rates problem is first you have to identify the known quantities and equations. And then after that, you have to differentiate with respect to time. And when you're differentiating, make sure to keep using the chain rule. So I made a video before on implicit differentiation. So when you're differentiating and you get a variable that isn't t, you have to, add dr dt or d whatever dt. Because again, if you watch my implicit differentiation video, you know that we have to use the chain rule in those cases. Finally, after we differentiate with respect to t, we then have to solve and substitute our given values or quantities for the rate we want to solve for. So this process will make more sense as we do a couple of problems, but that's just the general gist of how to solve one. Okay, so let's say we have a balloon, a spherical balloon that's being pumped by a pump. Okay, so that's a pump, that's a balloon. And the air is being pumped into the balloon. So the air is being pumped at a rate of 4.5 feet cubed per minute. And we know, that's all we know. We also know that the radius is changing, we want to find the rate of the change of radius when the radius of the balloon is 2 meters. So in this case, the first step is to identify the known quantities. So we know the air is being pumped in at a rate of 4.5 feet cubed per meters, which is a change in volume. So I'll say volume is V, dV dt is 4.5. And we want to solve again, we want to find the change in radius at when the radius is 2 meters or 2 feet. Yeah, that's what we want to solve for. And we need to identify the equations we know. We know the equation for a sphere. So in the AP Calculus BC exam, they're going to give you all the geometric equations if you need them. But in this case, the volume for a sphere is 4/3 pi r cubed. You don't need to memorize this because again, they're going to give it to you on the exam. And so now, second step, differentiate with respect to time. So we differentiate, we get dv dt equals, so r cubed becomes 3r squared. The 3 cancels out with the 3, so we get 4 pi r squared. And times dr dt, because again, we have to use the chain rule because we're differentiating r with respect to t. So by implicit differentiation rules, we have to use the chain rule in this case. So now we need to isolate, well actually now we can just plug in our values, right? So if we plug in the values we know, so we get 9/2 equals 4 pi r squared, so r is 2, so times 4 dr dt. And again, we're looking for dr dt, so we just isolate dr dt. We do so by dividing by 16 pi, which leaves us with our final answer, 9/32 pi. And the units, it's radius, change in radius per minute, so 9/32 pi feet per minute. And that's our final answer. So again, the process with these related rate problems is first you identify the known quantities that you know, your primary equation, and then if you can, you differentiate it, and you then use your known quantities, plug it in, and solve for whatever rate they're asking for you to solve. Okay, let's try another one. Let's say that we have a ladder, a 10-foot ladder, like so, and it's up against the wall and the ground. And let's say this ladder is moving this way, right? And it's moving at a rate of 1.5 feet per second. And we want to figure out how fast the height is changing. So this, how fast height changing when the ladder is 6 feet away from the wall. Okay, so let's do our known quantities. We know that we'll call this x, and we'll call this y. So we know that x is equal to 6. We know that dx dt is equal to 1.5, because again, it's changing. X rate is changing 1.5 feet per second because the ladder is moving away from the wall. And we know, we also know y, right? Because if 6 is here, 10 is the hypotenuse, right? And this is a right triangle. Then by Pythagorean triplets, 3, 4, 5, we know that y has to equal 8, so we know that too. Okay, and our primary equation is going to be, if we use Pythagorean theorem, x squared plus y squared equals 10 squared, or x squared plus y squared equals 100. Great, so now we have to differentiate with respect to time, so we get 2x dx dt plus 2y dy dt equals 0. The 2's cancel out, right? Because it's 0 on this side. And we can plug in our known quantities now. So we plug it in. So 6 times 3/2 plus, and for y, 8 dy dt. So here we get 9 equals negative 8 dy dt. And so divide by a, we get dy dt is equal to negative 9 divided by 8. And the units are going to be feet per second, because our feet per second is the unit for dx dt. And that's our final answer. And again, the process is fairly simple. We just have to look at the diagram, maybe draw a diagram. That's the first step, I think. Then we identify our known values, an equation. We differentiate the equation, plug in the quantities we know, and solve for whatever rate they're asking us to solve for. Let's do one more problem. This one's going to be a more challenging problem, and we'll have to do a little creative thinking here. So let's say we have a cone, like so, and water is being filled into it at a rate of 2 meters cubed per minute. Okay, and we know that the height of the cone is 12, and the radius of the cone is 6. Okay, great. So that's our diagram, and we want to find, again, let's just say we're finding the change in height, so we're finding dh dt at h equals 4. Okay, so that's what we want to try to find. Let's see, what do we know? So we know that our dv dt is 2, because water is being added at 2 meters cubed per minute. And we know that the height, we want to find dh dt when the height is equal to 4, like so. And we also know our primary equations can be volume equals pi thirds r squared times h. Okay, so we do have some information, but let's try, that's all the information we know at the moment. We can't really factor in the height anywhere because, again, our height's not going to be 12, it's going to be something different. So, okay. So we have that. And also we know one more thing. We know that if the height is 4, right? We know the radius has to be 2 at that point. So we know that too. Great, so this is all the quantities we know. Let's try differentiating this, see what happens. So we get dv dt is equal to pi thirds, and again here we have to use the product rule, so 2rh dr dt plus r squared dh dt, and we're looking for dh dt, right? So let's just look at this equation. We have dv dt, we have radius, we have height, we don't have dr dt, we have radius, we don't have dh dt. So we just came into a corner, right? Because we have one equation, but we have two unknowns, right? And so we can't solve it for two unknowns with just one equation. So this equation won't work because, again, we don't have dr dt. We don't know the rate at which the radius is changing. So before you give up, there is one trick we can do here, and this is creating a new equation that we can then plug into this equation to remove r squared. You may be wondering, how can we do this? Well, think about it. We have a triangle, right, where the height is 12 and the radius is 6, right? And so if we draw another triangle here, it's going to be similar by angle-angle similarity, because we have a right angle, angle, so angle-angle similarity. And so if we call this here h, because that's what it's being called, we call this r, then we know based on similarity rules that r divided by h has to equal 6 divided by 12, which is 1/2. Now, what you can see what we can do here, we can say r is equal to h over 2, and now we can plug it into this equation to get rid of the r. So whenever you have a case like this where you have an unknown that you can't solve the actual answer for because you have two unknowns, the idea is you have to create a new equation somehow and plug it into the old equation to get rid of that unknown. So in this case, we use the property of similar triangles to create a new equation that we can now plug into the old value. So now if we plug in this value, we have volume equals pi thirds times, so r squared h squared over 4 times h. So volume is equal to pi over 12 h cubed. Differentiate, we get dv dt is equal to pi over 4 h squared dh dt. Plug in our known values. We know that dv dt is 2. H squared is 16. 16 divided by 4 is 4 pi dh dt. And so our final answer, dh dt, is equal to 1 over 2 pi. Units are meters per minute. And that was our challenging related rates problem. Okay, so just to go over what we did here. So we, again, identified all the quantities that we knew. Then we tried differentiating the original equation, but it didn't work because we had a dr dt and a dh dt, meaning we had two unknowns. So instead, we had to make a new equation. And with this new equation, we were able to cancel out our r value. And then when we differentiated, we were able to then solve for dh dt using our known quantities, and we got our final answer. So that's the general process for a related rates problem. If you have any questions, leave a comment down below, and be sure to subscribe for tomorrow's video. Thank you guys all for watching, and I'll see you guys all tomorrow. Bye.